Question 1 is an Excel question. We're told the manager of a restaurant in Southbank, Melbourne has tables inside the restaurant and others outside on a balcony overlooking the Yarra River and Grand Building off Flinders Railway Station. We're also told that he believes the number of reservations for tables in the restaurant relates to various factors such as days of the week, time of year, and special activities in the city. Since his restaurant requires bookings to get a table, this does not need to be predicted. However, he believes that the proportion of tables he needs to set up outside relates directly to the temperature for the day. And so what he's done, he's collected some data over a sample period of 15 days, and the data consists of the average forecast day temperature for the previous day, as well as then the proportion of tables outside. His logic is that the forecast for the following day's peak temperature, which is usually around lunchtime, is generally correct, and he will be able to determine the number of tables required for outside and inside fairly accurately from each day's forecast temperature. So what we need to do is basically run some regression analysis so that we can build up that relationship between these two variables. For part A, we have to do a scatter diagram, so we'll start with that. Okay, so we've got our two columns of data. I've just copied them straight from the question sheet into Excel. Now here we're looking to predict the proportion of tables outside. So this is going to be our dependent variable y, and that means that x will be the average forecast temperature. Now, in Excel, when we go to create a scatter plot, the order of the columns is important. By default, X will treat the column on the left as X and the column on the right as the Y. So if we block on those two columns, because they're in the correct order for this particular research question, we can then just go to Insert, Scatter, choose a basic scatter plot, and Excel does all the work for us. Now, a little bit of tidying up. We've already got a heading. We can just use the heading of the variable for our y, which is fine. We don't need a legend. It's just one series, so we'll delete that. But we will add in some labels. So for the horizontal axis, we can put in temperature. And for our vertical, we can put in proportion, which of course is in percentage terms. Now we can also add in a trend line just by right-clicking on any one of those points, saying add a trend line, check that it's linear, close, and Excel has in fact put the regression equation, the line of best fit, onto that diagram for us, and we can see that the points, it's definitely a positive relationship. The higher the temperature, the higher the proportion, and the points are quite close to that line, indicating that we have a strong correlation, or reasonably strong. We'd need to of course work out that actual figure, but we will get that as part of our full regression analysis in Excel, or we could just work it out separately using the Correl function. Now part B, we have to use Excel to find the regression coefficients for our equation. Now we can do that either by looking at functions individually, and if you don't have the data analysis toolpack, this will be the way that you would do it. So we'll do that first. It's just equals to say it's a function, slope, open brackets. Now it is important for these types of functions to follow Excel in terms of putting in the y's first and then the x's. So I block on my y's, comma, block on the x's, close brackets, hit enter, and I have my slope, which of course is B1. And I can do my intercept, which is B0, or also known as C. Now to do that, I just use the intercept formula. So intercept, open brackets. Again, Excel wants the y's first, followed by the x's. Okay, so I might just round those off to 2 decimal places. We have the slope 2.21 and we have the intercept negative 24.69. Now, if I was doing this by hand and I wanted correlation, I would just use the Correl function. For Correl, it doesn't matter which way you do the x's and y's. You'll get the same result either way. And we've got correlation as 0.94, which is exactly what we thought it would be. It's quite strong. and positive. Okay, so that's how we would go about getting those figures if you don't have the analysis tool pack. If you have the analysis tool pack, we can go into data, we can go to data analysis, we can select the regression tool, say OK. Excel will ask us for the Y's and the X's, so I can go in, I can block on those. I'm going to block on with the labels, do the X's. But in using the labels, I must just click that labels box, and I'm going to let the output go to a new worksheet. So I say OK. Excel generates that large summary for us. The values, of course, that we're interested in are the coefficients, which I'll just highlight. So we've got the negative 24.69 if it was rounded to two decimal places, and then 2.21 for the slope. Okay, and multiple R, of course, is the absolute value of correlation, 0.94, and since our slope is also positive, we know that correlation is positive as well. Now remember, we did say that even if you don't have the tool pack at home to try this, that it's still important that you can read this type of output, and we have the example in the lectures. It's quite common to show regression analysis in this Excel format, and so you need to be able to find those three values from the output. In terms of calculating them yourself, well, you've got the option of either the tool pack or the individual functions. Okay, so just to finish off this question for part C, we have to interpret the meaning of slope. Now remember, generally, when we're just talking about X and Y, the slope represents the average change in Y for a 1 unit increase in X. So if we put that into the context of the variables that we're working with here, we can say a 1 unit increase in temperature increases the proportion of tables to be set up outside by 2.21%. So that's a useful bit of information. It tells us the rate of change of the proportion of outside tables based on increases to temperature. For part D, we have to do a prediction of the proportion of tables outside when the forecast temperature is 30 degrees. Now I'll just switch back to the first spreadsheet. The way we can do a prediction is we just use the regression equation and substitute in our value. So our regression equation is just going to be the intercept, negative 24.69, plus 2.21 times x. So that's our regression equation, and all we need to do is substitute in the x, which in this case is 30 degrees. So I'm going to let Excel do the work for me. I'm going to set this up as equals 24.69 plus 2.21, which is the slope, and that's times 30, our value of x that we're trying to predict. Hit enter, Excel does the calculation. You could have just as easily completed this on a calculator. We get 41.61, so that is the percentage of tables that we'd have to set up based on our regression analysis.